You can also run Python on Compute Canada clusters. Here I check for all available Python modules. I see module avail Python, and then I find the module that I would like to run, and then I load it into my environment. Next, I use the virtual env command to create a new virtual environment called Astro in a directory Astro in my home directory. So virtual env will install Python 3.7 right into the Astro subdirectory. Then I can source this environment by typing source astro bin activate. And then in this environment, I have the pip command, which is the standard Python package manager. I can type pip install --no index --upgrade pip, and that will upgrade pip itself. Then I can type pip install --no index, followed by the list of Python packages that I want to have installed in my environment. --no index will make sure that if we have this package available on Compute Canada clusters, it will first check that version, and if we have not compiled this package, then it will go to online repositories and download it from there. We also have a command avail_wheels to check for all available versions of any package. Let's say you are interested in TensorFlow and you specifically want to run TensorFlow on a GPU. So we have packages called TensorFlow_GPU, many different versions of this package. Let's say for some reason you cannot run the most recent version, TensorFlow_GPU 2 point something, you want an earlier version. Well, you can easily install any version that we have available. For example, if you're interested in the version 1.14, you can type pip install --no index TensorFlow_GPU == and then the version number. So this process will create a virtual environment with Python 3.7 and all packages that you installed in the folder Astro in your home directory. Next time you log into the cluster, you can type source astro bin activate, and that will load this newly created environment. Then you start Python, and then all the packages that you just installed will be available to you. The nice thing is that on the same cluster, you can create as many virtual environments as you need, and you can switch between them very easily. For example, let's say you want to have Python 3 and Python 2 environments. You can actually do that very, very easily with this virtual environment command. You can run Jupyter notebooks inside scheduled jobs on our clusters, and there are actually several different ways you can do that. So one of the ways is shown on this slide. You can schedule an interactive job, and inside this interactive job, you can launch a Python notebook server. It will print the name of the compute node on which this server is waiting for an incoming connection, as well as the secret token number. And then back on your laptop, you can organize SSH port forwarding from the port 8888 on your laptop to the port 8888 on a compute node where you have the Jupyter notebook server running. And then once this port forwarding is established, you open your browser, point it to localhost port 8888, and then you supply the secret token so that nobody else can connect to the same notebook server. We have pages in our documentation that tell you exactly how you can connect to a remote Jupyter notebook from Windows, as well as how you can use RStudio and several other languages inside Jupyter notebook sessions. Similar to Python, you can run R on our clusters. You would start by checking which versions of R we have available. Instead of using module avail command, you can use module spider command, which will typically give you more options. And then you find the version of R that you want to use. You load that module, and then you start the R shell by typing capital R enter. And then right from the R shell, you can install packages from the online repository. If you have downloaded a package as a gzip tar file, then you can simply install it from the bash shell by typing R command install-l, your destination directory, and then the package name. There are many different packages in Python and in R as well. There's actually MPI package for Python. There's MPI for R. There are various data I/O libraries, linear algebra libraries, etc. And at the bottom of this slide, I have a couple of scripts that show you how you can launch a number of jobs with the same R script, and these jobs will run as a job array. Because we have not talked about Sloan and we have not talked about job arrays yet, I will leave this as an exercise for later time.